Hello everyone. Yesterday I update the results of assignment 2, and this is the last update of assignment 2, and you can take a look of the results. And I also update the results of assignment 3. And if you want to rewrite, if you don't want to use the code template, you want to rewrite the whole program, then you must ensure that the outputs of your program are the same as those of the code template. Otherwise, your output format will be not consistent with the specification of assignment 3. And I also posted the results of the midterm exam, and you can see your grades from this file. And you can also find your answer paper in this folder. And for the questions and the corresponding answer, you can watch this video. And if you have any problems about the midterm exam, you can contact me. And in the previous week, we learned how to test and debug functions. This slide introduces 4 methods to test your programs. The first method is to use cout to print the values of variables. And the second method is to use the debugger. Usually, your programming environment will have a debugger. And your programming environment usually will have a debugger. For example, if you use the online IDE, then you can click the debug button. And you can see some guide about how to use the debugger. And if you are interested in how to use the debugger, then you can try this feature. And the third method for testing is to use the assert macro. And I have introduced how to use the assert macro. And the fourth method is to use stubs and driver programs to test your functions. And given a problem, and we usually adopt the divide and conquer approach to solve a problem. We usually divide one big task into smaller and manageable tasks, and design for each smaller task, we can design a function to solve the smaller task. And then after each smaller task is finished, then we combine all the solutions. And this next we will show how to test each function. This is one example. For example, we write a function uniprice, and we want to write a test function to test uniprice. And this function has two inputs, diameter and price, and this function has one output. And so in the main function is a driver function to test uniprice. And we use cin to let users to input the two parameters, diameter and price. And then we call this function uniprice and see out the output of uniprice. And we can inspect the output of uniprice to see whether the output is correct or not. And then this test is finished. And then we can the next cin read user input. If the user inputs y, then this means we want to continue the test. If the user input characters other than y, then this test terminates. So this is a driver program to test your own function. You can use this program to test any function you write on your own. But for some applications, but this program requires user interaction. You need the user to manually input the diameter and price. But for some applications, you might want to automatically test your own function. So if you want to automatically test your function, you can save the inputs in an array. For example, you can save many values of diameters in an array, and you can save many values of price in another array. Then you can write a for loop. Then inside the for loop, you can call the UniPrice function, and with the inputs from the two arrays, then you can perform the test automatically. And in this way, you don't need user interaction. And we usually write program incrementally. Incrementally means you improve your program step by step. We usually won't make a big change to our program, because if you make a big change to your program, then when there is a bug, it will become very difficult to find a bug, because you made too many changes. But if you only made small changes every time, then it is easy to find a bug, because you only made some, because you only changes a few lines. So we usually develop our programs incrementally. And we can write big picture functions first. For example, we can write the driver program first before we finish the design of UniPrice. You can write the driver program first, and we can delay the design of UniPrice. And to do this, we can simply let UniPrice return a value of double. This is not valid, but this is called a stop, because we want to run the driver program first. So we can skip the body of the UniPrice first, and return a proper value of proper data type. And in this way, the driver program can run. And later, when you have enough time, then you can return to the design of UniPrice. Then you can fulfill the details of this function. And this technique is called stop out functions. This technique allows you to write big picture functions first. And beyond the 4 methods to test your function, there is still one more fundamental method to test your function. this method is to manually check your program line by line, and you should be able to you should ensure that the logic of your program is correct. This is the most fundamental method, and I suggest you to use this method because for our assignment is very simple, and so you can easily inspect every line of your program. So I suggest beyond the 4 methods, you can examine your program line by line. You must ensure every the logic of your code is correct. But if your program is very complex, for example, if your program contains more than 1,000 lines, then you need to use the methods presented here to help you to test your functions. And the next slide is about the fundamental testing rule. And this rule is to test every function in a program where every other function has already been fully tested and debugged. Usually when we want to solve a problem, we require the use of many existing functions. These existing functions are defined in libraries. Such as cstdlib or algorithm library, and the functions defined in this library are fully tested and debugged. So the functions defined in this library can be trusted. But when we want to write our own function, we should also test our functions to ensure our functions works properly. And we have finished this chapter, and then we will go to the next chapter. The next chapter is about pointers and dynamic arrays. And this chapter has 3 parts. The first part is about pointers. The second part is about dynamic arrays. And the third part is about classes. And the classes is about data type defined on our own. And I will skip this part first. So I will introduce the first two parts, and after we learn how to define our own data types, then we will return to visit the third part. And I will use one example to introduce what is a pointer. For this example, we declare an array A, and this array has 5 elements, 1, 2, 3, 4, 5. And on the right-hand side figure, I visualize the array A, and suppose the memory address of each element of array A is shown as in this figure. And suppose the memory address of the first element is 4000, and the next memory address is 4004. And because each element is an integer, and one integer is 4 bytes. And then we know that the corresponding memory contents for each memory address is 1, 2, 3, 4, 5, because the initial value of the array is 1, 2, 3, 4, 5. Then in the next line, I declare another variable P. The data type of P is int star, and the int star is called a pointer to an integer. And we know that this variable P has its own memory address, and the value of the pointer is a memory address, which is the memory address of the first element of array A. So the value of a pointer is memory address, and this is different from an integer. An integer variable, the value of an integer variable is an integer, while the value of a pointer is a memory address. And the next line also declares a variable Q, and the Q is of data type int star. And this variable Q is a pointer, and the value of Q is 4008, and which is the third element, which is the memory address of the third element of array A. And the last line is about pointer subtraction. I will later we will learn pointer arithmetic. So later I will come back to this example. So what is a pointer? A a pointer is a data type, and the value of this data type is the memory address of a variable. And the call by reference, we have learned call by reference in the previous chapter. And this mechanism is related to pointers. And later we will see their relationship. So pointer is a data type. For this example, double star p declares a variable p, and this variable is a pointer to some double variable. We can see one example. For example, I declare a variable, a pointer p, and now suppose I try to assign integer value to the pointer, and let's see what will happen. And for this example, we know that this is syntax error because the compiler says invalid conversion from integer to int star. For this assignment, on the right hand side is an integer. The data type of 10 is integer, while on the left hand side, the data type of p is int star. So the two on the right hand side and on the left hand side, the two data types are different, so we cannot perform the assignment. And therefore, the compiler issues the error message. And the correct way to use pointer is, for example, we declare another variable v, and the v is an integer. Now we can let the pointer points to the integer, and to do this we need to use the AND operator. And on the right hand side is AND v, and the AND will take the memory address of the integer variable v. So on the right hand side will be int star, because on the right hand side is the memory address of an integer, and therefore on the right hand side the data type is int star, and on the left hand side the data type of p is also int star. So this assignment is legal. So now we can compile this program. without any error. And if we declare p is a pointer to integer, then you cannot let p to point to other data types. For example, we cannot let p point to some double variable. If you do this, the compiler issues error message, because on the right hand side is the memory address of a double variable, and which is double star. So on the right hand side, the data type is double star, while on the left hand side, the data type is int star. And the data type are not consistent, and therefore we cannot perform this assignment. And if you can try to force the compiler to perform assignment, and for example, you can use typecasting to change the data type of this memory address to int star. Then the compiler will pass this. Then the compiler will not issue any error message. But this way is not recommended. This way is dangerous, because you try to typecast the memory, because you try to typecast because typecast can be dangerous. If you try to typecast from one data type to another data type, the reason is that the memory size of each data type is different. If you try to typecast from one data type to another data type, this can cause some problem. So it is not suggested to manually perform typecast. And in this slide, we will learn how to declare pointer variables. For example, for this line, in this line we declare the variable p1, and the p1 is a pointer to integer variables. And after p1, there is another variable p2, and we know that before p2 there is a star. So p2 is int star. So p2 is also a pointer to integer variables. And after p2 is another variable v1, and v1 is ordinary integer variables. So v1 is not pointer. V1 is just ordinary integer variables. And v2 is also ordinary integer variables. So if we want to declare pointers then we need to add the star operator before variable name. And in this way will produce pointer to the data type. For example, after int you add a star, then this will produce a pointer to an integer. And there are when you declare pointer variables, you can determine when to put the space. Both ways are accepted. So you can let a space before the star, or you can let a space after the star. Both are accepted. And you can also remove the the space. So the space will not affect the declaration of pointers. But usually we will use the second one. Usually we will adopt the second way. Because this way it is easy to inspect that P2 is a pointer to integer. So we usually use the second method. And we know that pointer is an memory address, and address is an integer. But pointer is not the same as an integer. We have seen one example. A pointer is of another. The data type of pointer is int star or double star, while the data type of integer is int. And they are of different data types. So we cannot treat pointer as an integer. And in C++ or in C, pointer is an abstraction of memory address. So in C++ or in C, pointer becomes one data type. And the pointer is treated as an abstraction of memory address. And therefore, we cannot use pointer like integers. So we cannot assign integers to a pointer, because the data types of 10 and the data type of P2 are different. Next, we will learn how to point in a pointer to the integer variable. First, we declare pointers. P1 and P2. And we also declare integer variables V1 and V2. And now suppose we want to point P1 to the V1 integer variable. Then we can use this syntax. Before the V1 variable, we add the AND operator. And this operator will determine the address of V1. So on the right hand side of this, on the right hand side is the memory address of V1. And therefore, on the right hand side, the data type is int star. And we can assign the memory address to the pointer P1. P1 is also of int star. And this line reads like P1 equals the address of V1. Or we can say P1 points to V1. And if we want to access the value of V1, we can use this syntax. For example, we can assign 1 to V1. This is the usual assignment. We simply assign the integer value to the integer variable, or we can via the pointer, or we can assign 1 to star P1. And here, for this line, the star is called the dereferencing operator. And this operator is to get the data that P1 points to. So in this line, the star is called the dereferencing operator. And star P1 will get the value of V1. So this line is equivalent to the previous line. The two lines are equivalent because star P1 equals V1. This way is less direct, but later we will see why sometimes we need to use this way to change the value of an integer variable. Next, we have another example. Suppose we declare an integer variable, and suppose its initial value is 0. And next, we declare a pointer P1. Then we assign the memory address of V1 to the pointer P1. And here we used the AND operator. This AND operator can get the memory address of V1. And then we try to modify the value of V1. So we can in here we assigned 42 to V1. And here we use the dereferencing operator star P1. So after these statements, we can print out the value. We can print the value of v1 and star v1, and the two value are both 42. So star p1 and v1 are the same, refer to the same variable. And for beginners, we should note the example of this line. For this line, we declare a pointer p1, and we also perform initialization. We assign the memory address of v1 to pointer p1. So this line is equivalent to we declare p1 first, and then assign the memory address of v1 to p1. So this line is equivalent to the two lines. And for this line, it is for beginners often confused with this operator. For this line, the star is not the dereferencing operator. So for this line, here star is not the dereferencing operator. So here star p1 does not mean v1. Here you should combine int with star. Here int star means one data type. So so here you should combine int and the star, and int star is a data type. While in the bottom line, and in the bottom line here, star is the dereferencing operator, and the star p1 means v1. So it is important to distinguish which star is the dereferencing operator. If we declare a pointer, then here star is not the dereferencing operator. But when we use this line, when we perform assignment like in this line, then in this line star is the dereferencing operator. And let's take a break for 10 minutes. In next hour we will have a quiz to review some contents of the previous week. Hello everyone, and we will have a quiz. So you can log in your Ruvio app first, and please raise your hand if you need papers. Please close your laptops if you use laptops. And I turn on the first question. 30 seconds left. And I will turn off this question. The second question is turned on. Uh, 30 seconds left. And I will turn off this question. 20 seconds left. I will close this question. If you use paper, remember to write down your student ID and your name. If you, I will collect the paper. Let's see the answer of the first question. And the answer is the first option. Let's see the question. This function has two inputs. The first input is called by value, while the second input is called by reference. So after this function call, the value of the first variable will not be changed. So after this function call, the value of VAR1 is 3. So the possible answer is the first one or the second one. And we need to determine the value of VAR2. VAR2 is called by reference, so the value of VAR2 will be modified after this function call. And the first line, x is minus 2, so 3 minus 2 is 1. And the second line, x plus 4, 1 plus 4 is 5. So the value of y is 5. So after this function call, the value of y is 5. And therefore, the answer is the first option. For the second question, the answer is the answer is the third one. And this function has two inputs, and we see both inputs have the AND operator. So both inputs are called by reference. So after this function call, the values of VAR1 and VAR2 might be changed. And we know that the initial value of VAR1 is 5. and the initial value of VR2 is 3. Then for this line, y is assigned to x, so VR2 is assigned to VR1. So the value of VR1 becomes 3. And then x is assigned to y. Now the value of x is 3, so 3 is assigned to VR2. So the values of VR1 and VR2 all become 3. So the value of VR1 and VR2 are 3. So the correct answer, the answer is the third one. And the function name is a hint for the answer because it's pseudo, not real. So it's not a real sweep, it's a fake sweep. The third question. The correct answer is the second one. Suppose the purpose of the function rescores is to let users input scores into the integer array, and then this question asks, is it semantically correct to declare this function as this line? And the answer is no, because in this declaration there is the const keyword. If we use const here, means we cannot modify the value of scores inside the definition of rescores. So if we add const here, then this means we cannot modify the value the values of scores in the definition of rescores, and this is and this obey our purpose. So it is not semantically correct. We should remove the const keyword here. So the answer to this question is no. If no further questions, we will return to the slides. This slide introduces pointer assignments. For this example, I declare two pointers, P1 and P2. And if I assign P1 to P2, then this assignment is called pointer assignment because it assigns one pointer to another. And the meaning of this line means to make P2 point to where P1 points. Later we will have an example about pointer assignment. And this pointer assignment is different to this line. This line is integer assignment. Is the ordinary integer assignment. So this line is not pointer assignment. This line is the purpose of this line is to assign value pointed to by P1 to value pointed to by P2. And I will use an example to illustrate pointer assignment. For example, in this example, I declare two integers, v1 and v2. And the initial value of v1 is 5. And the initial value of v2 is 2. So, and the next line, I declare a pointer p1. P1 is pointing to v1, and the pointer p2 is pointing to v2. And we can visualize this line as this figure. P1 is a pointer, and it is pointer to it points to v1, and the value of v1 is 5 because the initialization, and the p2 points to v2, and while the value of v2 is 2 because of the initialization. And then we perform the pointer assignment. We assign P2 to P1. And let's see what happened. If we assign P2 to P1, then we will have this figure. If we assign P2 to P1, then P1 will point to V2. So pointer assignment change the direction of the arrow. So originally P1 is pointing to V1, but after the pointer assignment, the arrow is pointing to V2. So pointer assignment change the direction of the arrow. And next, let's see another example. We assign star P2 to star P1. And this line is not pointer assignment. The figure for this line is this one. If we assign star P2 to star P1, then this means we assign the value of V2 to V1. So the value of V1 becomes 2. If we assign star P2 to star P1, then this means we assign the value of star P1. The value of star P1 is V2. So we assign 2 to star P1, and star P1 is V1, so we assign 2 to V1. So the value of V1 becomes 2. So after this assignment, the value of V1 is changed. And this assignment is not pointer assignment. We know that the direction of the arrows are not changed. And the next slide introduces operator, the new operator. The new operator is to dynamically allocate memory space. And for example, if we want to dynamically allocate an integer variable, we can use new int. And the new operator will return a pointer to the new variable. So a pointer to integer is int star. So we need to declare a pointer p1 of data type int star. We can print the value of p1 and star p1. The value of p1 is memory address, so it is in hexadecimal because p1 is a memory address, and the value of star p1 actually is unknown because we did not initialize star p1. And if you want to give initial value to star p1, you can add parentheses and give initial values. So if so I add a parenthesis after integer, then inside the parenthesis I input 10. Then the initial value of star p1 will become 10. And this is another example. Let's see this slide. First, we declare two pointers, p1 and p2. Both p1 and p2 are int star. And because p1 and p2 are not initialized, so the initial value of p1 and p2 are unknown. And later we use new to allocate the memory space of an integer. And the new operator will return a pointer to int. And we assign this pointer to p1. So this assignment is actually a pointer assignment. So p1 will assign to p1 will point to the memory space created by new. And later we assign 42 to star p1. And therefore the value of this question mark becomes 42. And then we assigned p1 to p2. And this assignment is a pointer assignment. This assignment creates one error. P2. Now the pointer p2 points to the memory space created by new. So after this pointer assignment, both p1 and p2 point to the same variable. And the next, if we assigned 43 to star p2, then the value of this variable is changed from 42 to 53. And then if we create, if we use new to allocate a memory space of one integer, then this will return another pointer. We'll return a pointer, and then we assign this pointer to P1. So P1 will point to the memory space created by this new. And because we don't perform initialization, so the initial value of this variable is unknown. You can try to copy this example to the IDE and to see the values of the variables. First we declare two pointers, P1, P2, and P1 points to the allocated memory space, and then 42 is assigned to star P1, and P1 is assigned to P2. And if we print the values of star P1 and star P2, they are both 42. Because P1 and P2 point to the same variable, and the variable is of value 42. And the next, if we perform this line, then the value of star P1 and star P2 becomes 53. And then if we use new to allocate one variable, to allocate one memory space, and then P1 is point to another variable, and we assign 88 to star P1, and then we print the value of star P1 and star P2. You can also try to print the memory address of P1 and P2. For example, you can after this line, I print the memory address of P1 and P2, and for this line, P1 and P2 are the same memory address, and for this line, P1 and P2 are also the same memory address, but for this line, P1 and P2 are different for this line, because P1 is pointing to a new variable, a new integer. So after this line, P1 and P2 are pointing to different variables, and therefore the memory address of P1 and P2 become different. Next, I will introduce why we need to learn pointers. Pointers play an important role in the C programming language. Because in the C programming language, if we want to achieve call by reference, then we need to use pointers. But in the C++ programming language, actually we don't need to use pointers to achieve the call by reference mechanism. In C++, for example, if we want to swap two inputs, we can define this function. And to swap two inputs, we use the call by reference mechanism. And to use call by reference in C++, we add the AND operator in the function definition. But in the C programming language, the C programming language does not have this syntax. So in the C programming language, we cannot use this function, or we cannot use this syntax. In C, we need to use pointers to achieve the call by reference mechanism. And let's see how we can use pointers to achieve call by reference. The purpose of swap v2 and swap v1 are the same. The purpose of both swap v1 and swap v2 is to change the values of the two inputs. And now suppose the first input is a pointer to some integer, and the second input is also a pointer to some integer. And inside the function definition, we need to change the values of the two inputs. And first, we create a temp variable to store the value pointed by P1. And the star P1, here star is the referencing operator. And star P1 gets the data pointed by P2. And the next two lines swap the values of star P1 and star P2. And therefore, actually, swap v1 and swap v2 do the same task. And let's see how to call the two functions. If we want to make a function call to swap v2, first we declare two integers. Then we assign the two the inputs of swap v2 are the two integers n1 and n2. But to use swap v1, we need to input pointers. So we need to input pointers to P1. And pointer means the memory address of the integer. So to input pointer, so we need to add the AND operator. Because the AND operator can get the memory address of n1. And the memory address of n1 is an int star. So to use swap v1, we need to input two pointers. And the first pointer is AND v1, n1, and the second pointer is AND n2. And both functions, swap v1 and swap v2, can be used to exchange the values of the two inputs. For example, you can copy the code here. Or you can download the code provided in the reference web page. So I copy the swap v1 and swap v2. Then in the main function, I declare two integers, n1 and n2. Then I make a function call to swap v1. Later I made a function call to the swap v2. And you can see initially the value of n1 is 2 and the value of n2 is 5. And after swap v1, the values of n1 and n2 are exchanged. And after swap v2, the values of n1 and n2 exchanged again. So both swap v1 and swap v2 can be used to exchange the values of the two inputs. And which version will you choose? You will choose swap v1 or swap v2. Please raise your hand if you like swap v1. Okay, raise your hand if you like swap v2. No answer. Oh, okay. I will choose. If I can choose, I will use swap v2. Because swap v2 is more intuitive, it's more direct. Because if you use pointer, then the function call you need to input pointers, and in the function definition you also need to use the dereferencing operator, and you will find the dereferencing operator or the pointer is less readable than the usual integer assignment. So I prefer the second version. I prefer version 2 because version 2 is more readable. But if you use the C programming language, then you have no choice. You can only use the first version 1. But if you use the C++ programming language, you have choice. You can choose Swipe version 1 or Swipe version 2. And let's take a break for 10 minutes. Hello everyone, and let's continue our class. And the next two slides introduce some usage about the new operator. But these two slides requires the knowledge of user-defined data types. So later, when we learned user-defined data types, then we will revisit the two slides. For now, I will skip the two slides. Next, we will enter the second part. The second part is about dynamic arrays. And what we have learned so far are static or automatic variables. Automatic means, for example, we define a variable inside the main function. Then when the main function is called, then the variable is created automatically. And the variable is destroyed when the function completes. And this is not dynamic. For example, in this example, I declare an array, and this array has 100 elements. This is static because I cannot change the length. I cannot change the size of this array after this declaration. The size of this array is always fixed. Its size is 100. Its size is 100 integers. So this is called static variables or automatic variables. But dynamic variables allow us to manually allocate the memory size. We can change if we dynamically allocate memory space, then we can change the size of an array. And later we will see how to do this. So dynamic variables is created with the new operator. And we can use new to create dynamic variables. And we can also destroy the dynamic variables, use the delete keyword. And when we use the new operator to allocate memory space, and the space is called heap or free store. When we want to use the new operator, then the new operator will allocate memory space from the heap. So all new dynamic variables are from a heap. And if there is no sufficient memory in heap, then the function then the calls to the new operator will fail. Here is one example. Previously, we used new to allocate the memory space of a double. Now, suppose we want to use new to allocate memory space for a double array. Then we add bracket after the keyword double, and then inside the bracket is the size of the dynamic array we want to declare. So, for example, you want to declare a double array of 100 elements. But if the size is too large, for example, if the size is too large, then when you run the program, then you will encounter an exception called bad allocate. This means bad allocation because the memory size you want to allocate is too large, and the memory heap does not have sufficient memory. So this time the new is fail, and the operating system will have an error of bad allocation. So for new compilers, for new compilers, if we want to check whether new is successful or not, we can use the try and the catch mechanism to determine whether the new operator is successful or not. So in C++, there are two keywords, try and catch. But this usage is more advanced, and is in chapter 18. And if you are interested, you can take a look at chapter 18 to know what is exception handling. So if you do not handle the exception, the program will terminate immediately. But you can choose to handle the exception, so you can let your program continues, and you can still do something after the exception happens. But if you do not do anything, then if the exception happens, then your program terminates immediately. This is for new compilers. For old compilers, this is very old, very old compilers. You can check whether the return pointer is null. Here null is a constant. Null is a constant. It is actually the integer 0. So for very old compilers, we will use this if statement to check whether the new operator is successfully called. And if p is not the null constant, then this means the new operator is successful. And the null constant will create one problem. Let's see the two function declaration. The two functions have the same name. This is function overloading. The function have the same name, but their input are different. The input of first function is a pointer, while the input of the second function is an integer. But if our function call is func null, suppose our input is null, then which function will be called? Both functions are possible because null is a pointer, so the first function is possible. The second function is also possible because null is integer 0, so the second function is also possible. And this will lead to ambiguity. So the use of the null constant will lead to the ambiguity problem. And in order to solve this problem, C++11, this is C++ specification defined in 2011. And the C++11 introduced a new constant, now PTR. It's in lowercase, now PTR. And then now PTR is not integer 0. So we will not have the ambiguity problem. So it is suggested that if you want to check whether the pointer is null, you can use the null PTR. Next, this slide introduces another operator called delete operator. After we allocate memory space, and when we finish the operation on some variable, then we need to return the memory. And when we want to return the memory, we can use the delete operator. The following is one example. For example, we use nude to allocate the memory space of one integer. And suppose the initial value of the integer is 5. And after we do some operations on the pointer PTR, and we want to return the memory, then we can use the delete key. We can use the delete keyword. And after this statement, any any operation on the pointer PTR is undefined because we already returned the memory space. And we do not recommend to use new and delete. We recommend you use the existing functions defined in the libraries, and we do not recommend to directly use new and delete. Because if you directly use new and delete, this will cause some problem. Because, for example, sometimes you might forget to use delete to return the memory. And if you do not return the memory, then your program will consume memory continuously. And finally, all your program of your operating system will be exhausted. So we do not recommend you to use new and delete. We recommend you use existing functions like the vector we will introduce in the next week. We will introduce vector, and the vector will automatically allows you to dynamically adjust the size of an array. Only for some very special applications, you need to use new and delete. For example, if your application is memory demanding, and this time you need to manually allocate memory, then this time you can use new and delete. But if your application is not memory demanding, then I suggest you use existing function defined in library. The next slide introduces another problem. This problem is called Dangling Pointers. If after we execute this line, after we delete the pointer, then this line will return the memory. So this line destroys dynamic memory. And after this line, if we want to, if we still want to access the value the pointer points to, for example, we use the dereferencing operator. We want to change the values where PTR points to. Then this will produce unpredictable results. And this might be disastrous, because if we return the memory. If we return the memory, then there might be some programs use the return the memory. And if we use this line to change the value, of the variable PTR points to, then this can change the behavior of the other program, and this will cause some unpredictable results. And this problem is known as dangling pointers. But sometimes it might be okay and nothing happens sometimes. So it is better to avoid dangling pointers. And to avoid dangling pointers, the textbook suggests after we delete PTR, we can assign the null pointer to PTR. And this line, after this line, if you use the dereference operator on PTR, then this line will do nothing. So the textbook suggests after we delete PTR, we can assign the null constant to PTR. The next slide introduces a new keyword type def. This keyword means type definition. We can use this keyword to define a new data type, or create an alias for. We can use this keyword to create an alias for existing data type. For example, we can use type def int star as another data type. Well, we can use type def to give the data type another name. For example, we can use int ptr as a name as another name for int star. We can use type def to give another name to int star. Then we can use this newly defined data type to declare pointers. So we can use this. We can use int ptr to declare pointers. So the two lines is equivalent to this one. The first two lines is equivalent to this one. And you can change int ptr to any name you want, or you can change int ptr to any name. For example, you can change and the use of type def can make your program more readable. So you can give meaningful names to existing data types. So properly using type def can make your program more readable. So when we write programs, we often use type df. Another advantage of type df is to shorten the length of a data type. In the next chapter, we will learn another data type called vector. And the length of this data type is very long. You need to type many English letters. Then you can use type df to shorten the length of the data type. So in the next chapter, we will revisit the type df keyword. And the third example is more advanced. It is related to function pointers. You can skip this example. If you are interested, you can search function pointers. And next, let's see pointer arithmetics. We can do addition and subtraction on pointers. Suppose we declare an array A of 10 elements, and the index is from 0, 1 up to 9. And next, we declare a pointer P, and we assign the memory address of A2 as the initial value of P. So P will point to the element of A at index 2. And later we create another pointer Q, and the initial value of Q is P plus 3. And here we use pointer arithmetic. What is the value of P plus 3? This is not an integer addition. This is pointer addition, because one input is pointer, and the other input is an integer. So this is a pointer addition. And the P plus 3 means the memory allocation, the memory address after 3 elements of integer. So P plus 3 means the memory address after 3 integers. So Q will point to the memory address of A5. Because A5 and A2, the distance between A5 and A2 are 3 integers. And later if we add P plus equals 6, then P will point to A8. Because A8 and A2, because the distance between A8 and A2 is 6 integers. You can try to print the memory address of P. the memory address of P is this one. And after this line, I add 1 to P, and this line is pointer arithmetic. This one is pointer addition. So P will be added by 4 because an integer is 4 bytes. So P will add by 4 because 1 means one integer. So P will be added by 4. And we know that 8, if 8 is added by 4, then we obtain 12. And 12 in hexadecimal is C, is letter C. So the memory address of P is this number. And if you add 3 to P, then we can print the value of P. And in this example, the value of P is C4. You can compute the difference between the two memory address. The difference between the two memory address is 12. This is pointer addition, and next, let's see another example. Suppose P is pointing to the element of A at index 1, and the Q is pointing to the element of A at index 5. And now suppose we perform P minus Q. And then what is the result of P minus Q? P is a pointer, Q is also a pointer. But the result of pointer subtraction is not a pointer, it's an integer. So this is somewhat unexpected because the result of pointer subtraction is an integer, not a pointer. And the result of pointer subtraction is the distance between P and Q measured in integer. So the distance between P and Q is 5 minus 1 is 4 integers. Is negative 4 because 1 minus 5 is negative 4. So the distance between P and Q is negative 4 integers. And if we perform Q minus P, then the distance between Q and P is 5 minus 1, which is 4 integers. So this is the pointer subtraction. And we know that if we want to perform pointer subtraction. Both pointers need to point to elements of the same array. In this example, both P and Q point to elements in array A. But if Q is point to elements of another array, then the pointer subtraction is not meaningful. And also, if you perform pointer arithmetic, but if this pointer does not point to an array element, and this operation is also not meaningful, and its behavior is undefined. You can also copy the code to IDE and to print in this example, I print the value of P and Q, and because P and Q are pointers, so the values of P and Q are memory address. And I perform pointer subtraction, and the result is an integer I, and the value of I is 4, because the distance between Q and P are 5 minus 1, which is 4 integers. So the value of I is 4. But if you look at the memory address of P and Q, the distance between the two memory address is not 4 bytes. It is the distance between the two memory address is 4 times 4, which is 16 bytes. 16 bytes, and so 9 plus 1 is 10, and the 10 is letter A. Because this is hexadecimal, this is in hexadecimal. Below is the usage of pointer to accessing the elements of an array. Suppose we declare an array, and we have many methods to access the elements of an array. Method 1 is previously we learned use method 1 to access the elements of an array, and we can also use pointers to access the elements of an array. Let's see method 2. And for example, first we declare a pointer p, and this pointer is point to the first element of the array. And you can use the array name for this. If you want to obtain the address of the first element of the array, you can use the array. You can just use the array name ARR. And next, we use the for loop to access the elements of the array. And we create index I as method 1. We create index I, and to access the element of the array, we use p plus I, and this is pointer addition. So p plus I is still a pointer. And then we use the dereferencing operator to get the value of the pointer. And method 2 is equivalent to method 1. The two methods are equivalent. And we can copy the code to IDE. Method 1 prints 52520, and method 2 also print 52520. So the two methods are equivalent. But we do not suggest you to use method 2 because it is hard to read. It is very difficult to understand what does this means. You must know this addition is pointer addition, and then you need to know the star is the dereferencing operator. So this syntax is difficult to read. So we do not recommend method 2. Another method to access the elements of the array is the third method. And here we use we create a pointer q, and the initial value of q is ARR. ARR is equivalent to the memory address of the first element. So ARR is equivalent to end ARR 0. And in each iteration, we add q by 1. And this is pointer addition. plus q is pointer addition. And until q is less than ARR plus ARR size. And if we want to access the elements of the array, then we can use star q. So method 3 also print 52520. And this style is more readable than method 2. You can find that this style is more readable than method 2. In the C programming language, method 3 is often used because in the C programming language, pointers are used very often. So method 3 is very popular in the C programming language. But in the C++ programming language, you can skip the method 2 and method 3. You can choose to use method 1. I prefer method 1 because method 1 is more readable than other methods. And method 4 is related to vector, and the vector will be introduced in the next chapter. So in the next chapter, we will revisit method 4. And the time is up, and let's end here.